As you can see, I've shown all my working out here already. I'm just going to talk you through it. So for part A, we need to prove that identity. So I'm starting on the left-hand side because there's clearly quite a lot we can do there. I'm rewriting this cot theta as cos theta over sine theta. And I'm rewriting the cot squared theta as cos squared theta over sine squared theta. Now, looking at this, we've got an awkward fraction and another fraction inside a bigger fraction. This is quite messy. So I want to tidy it up by getting rid of these fractions. So I'm looking at the top and the bottom, and as you can see, I've decided to multiply by sine squared. Because if I times the denominator by sine squared, it's going to cancel this out. And timesing the numerator by sine squared will also cancel this out as well. So, on the numerator, we've got 2 cos theta over sine theta times sine squared. Now, this sine theta here is going to cancel out one of those sine thetas. So I will be left with the 2 cos theta multiplied by the remaining sine theta. So on the numerator, we're left with 2 sine theta cos theta. On the denominator, we've got 1 times sine squared is sine squared. And as we said before, the cos squared over sine squared times sine squared. The sine squareds are going to cancel out and just leave me with the cos squared. Next, we're looking at this sine squared plus cos squared, and we know that that's equal to 1. So we're left with 2 sine theta cos theta over 1, which is 2 sine theta cos theta. And we know, hopefully we recognise that as being the sine double angle, which was what we needed to show. Right, part B says to use the result above to solve this trigonometric equation. And as you can see, I've seen that we've got a sine 2 theta written in here, which is what I had here. So I've decided to replace that with this 2 cot theta over 1 plus cot squared theta. So that's gone there. And one of the reasons why I did that is I could see that when I was going to times this 1 plus cot squared by the 1 plus cot squared from here, they're going to cancel out. So that's my next step. This cancels with this, and we get left with 4 cot squared theta plus 1 is equal to 2 lots of 2 cot theta, which is 4 cot theta. Subtract the 4 cot theta to get a quadratic. I've factorised that quadratic and found that we've got a repeated solution of 1/2. So cot theta equals 1/2. I know that cot is 1 over tan. So if I do the reciprocal of cot, I get tan. If I do the reciprocal of 1/2, I get 2. Tan inverse of 2 is 63.4. So on my graph, this is 63.4, which means that this will be 63.4. So 180 plus 63.4 gives me the 243.4. And those are the solutions to that equation.